All right, folks, this is the last video on features of the graphs of rational functions. What we're going to learn about, we already learned about vertical asymptotes and horizontal asymptotes, and now I'm going to show you how to identify a slant asymptote. Now, a vertical asymptote is a vertical line, okay, identified by x equals, right, like x equals 4. A horizontal asymptote is a horizontal line identified as a y equals, like y equals -3, okay? There's only 3 kinds of lines on a coordinate plane. There are vertical lines, there are horizontal lines, and then there are what you may call diagonal lines, or what we are going to call slanted lines, okay? And slanted lines look like this. Or, okay, they're basically linear functions, right? Like if we had a line on the graph that looked like this, oops, that's really sloppy, but let's pretend it's a straight line. Not doing very good here. We're going to forgive Mr. Ryan, okay? And this is the equation of a line that has a y-intercept of +3, b equals 3, and a slope of up 2 over 1, a slope of 2, and therefore this is the graph of y equals 2x plus 3, right? Well, slant asymptotes are exactly that same thing. Slant asymptotes are identified as a linear equation, all right? And what I'm going to show you is there's only really one qualifier. Like, it's really easy to identify whether a rational function has a slant asymptote. Here's how you're going to do it. A rational function has a slant asymptote if the power, meaning the variable power, the x power, if the power or degree of the numerator is 1 more than the power of the denominator. Okay? A rational function has a slant asymptote if the power of the numerator is just 1 more than the power of the denominator. So, for example, if we have y equals 7x to the 5th power minus 2x to the 4th plus x cubed minus 6x squared minus 3x plus 1 divided by 2x, well, let's just say x to the 4th. X to the 4th minus 7x to the 3rd plus 6x squared minus 3x plus 5. Okay? Then, because the denominator is 1 power less than the power of the numerator, this rational expression, or this rational function, would have a slant asymptote. Okay? And so, I'm about to show you how to identify what the slant asymptote is. And basically, the way that you identify a slant asymptote is through polynomial division. Okay, so what you're going to do basically is just to identify the slant asymptote, use polynomial division. Now, you can use polynomial long division, or you can use synthetic division. Now, you can only use synthetic division if the denominator power is the first power and the lead coefficient is 1. So like if the denominator was just x minus 7 and the numerator was an x squared, 1 power above, then you could just use synthetic division and find the slant asymptote. So use polynomial division to divide the numerator by the denominator, okay? And then ignore the rational expression in the answer or in the quotient. Okay, so when you get an answer, when you use polynomial long division, you know how usually you'll come up with something like 3x plus 5 minus 4 over, x to the fourth plus 9. I'm just making stuff up here, right? See how there's a rational portion? This would be your slant asymptote, just this. And you'd ignore the rational part. But let's go ahead and work through the example, and you'll see what I mean. So we're going to identify the slant asymptote of this. Now, I'm probably not going to give you anything this ridiculous looking. I'll probably break up. In fact, let's make this just a little bit easier. Let's get rid of a bunch of this. We'll leave the 6x squared in there. Let's do this. Okay? Here's going to be, we're going to identify the slant asymptote here. So we're going to do x to the fourth minus 7x to the third. We're going to divide that into 7x to the fifth minus 2x to the fourth plus x to the third minus 6x squared. Okay? 7x to the fifth divided by x to the fourth is 7x. 7x times x to the fourth is 7x to the fifth. 7x times negative 7x to the third, 7 times negative 7 is negative 49. X times x to the third is x to the fourth. Now we're going to subtract. 7x to the fifth minus 7x to the fifth, that cancels. Negative 2x to the fourth minus negative 49. Now, so what we got is, you might have to write it out, negative 2x to the fourth minus negative 49x to the fourth, right? That equals, this becomes plus, right? So negative 2 plus 49 is 47x to the fourth. Okay, all right, good. Then we're going to bring down the plus x cubed minus 6x squared. Now, what's 47x to the fourth divided by x to the fourth? Okay, well, that's positive 47. So we're going to put plus 47. 47 times x to the fourth is 47x to the fourth. 47 times negative 7x to the third is a really large number. Let's just grab the calculator. Do that. Negative 7 times 47 is negative 329 x to the third. And then 47x to the fourth minus 47x to the fourth cancels. X to the third minus negative. Minus negative, that means plus. This can become 330 x to the third power minus 6x squared. Well, look, this now cannot divide into this, and so the rational portion of our answer would become plus 330x to the third minus 6x squared over x to the fourth minus 7x to the third. But I told you at the beginning, for a slant asymptote, ignore the rational portion. You don't need this. This is your slant asymptote right there, 7x plus 47. So this has a slant asymptote at y equals 7x plus 47. And that is how you identify a slant asymptote. So, if the numerator is 1 power above the denominator, then do polynomial long division, and when you get the first two things, one of them with an x, and then one constant, that is your slant asymptote, and you can move on to the next step. Let's do another example. I'll show you what I mean. Let's do something a little less bulky here. All right, let's do 10x to the fifth. Let's not do a fifth power. Let's do a fourth power. 10x to the fourth minus 9x plus 1 over 5x to the third plus x. Let's try that. So the power of the numerator is 4, the power of the denominator is 3. Since the power of the numerator is larger than the power of the denominator, there is no horizontal asymptote. However, because the power of the numerator is 1 higher than the power of the denominator, then there is a slant asymptote, and we're going to use polynomial division. And last week you were supposed to watch, and you're supposed to do a bunch of problems with polynomial long division, and if you didn't do it, then you better go back and learn it now, because you got to know how to do this. You got a lot to learn if you skipped over that. All right. So now we got 10x to the fourth minus 9x plus 1. Now, remember, we only care about the front of each of these. What's 10x to the fourth divided by 5x to the third? 10x to the fourth divided by 5x to the third. Well, 10 divided by 5 is 2, and x to the fourth divided by x to the third is just x, right? So I'll put a 2x here. So that's the first part of my slant asymptote. I know my slant asymptote is going to be y equals 2x with now a y-intercept on it. 2x times 5x cubed is 10x to the fourth. 2x times x is plus 2x squared. Now we're going to subtract. 10x to the fourth minus 10x to the fourth cancels. Now there are no here. I'm going to move this minus 9x plus 1. I'm going to move that over. Minus 9x plus 1, because there are no x squares here. We got a 0 here, right? 0x squared minus 2x squared is negative 2x squared. Now we're going to bring down the minus 9x plus 1. And now, how many x cubes are there here? We don't have an x cubed. We need an x cubed. If there's a 0 here, that means we have 0 minus 2x squared. This is 0x cubed, which is just 0. What's 0 divided by 5x cubed? Well, that equals 0. That means there is that means that the y-intercept is 0. This is actually our slant asymptote. Our slant asymptote is at y equals 2x. Okay? Let's make it 13x squared plus 4x minus 93 over x plus 5. I want to do a particular example, so I got to change it up. Power of the numerator is 1 higher than the power of the denominator, and therefore there's a slant asymptote. But also notice the denominator is 1x to the first power. That means we can do synthetic division instead of polynomial long division. So we're going to do synthetic division here. What are we going to put in the half box? Well, it's the 0 of the denominator. What if you plug something in? What can you plug in for x and get 0? Negative 5, right? So we're going to put a negative 5 here. Then we're going to put the coefficients of the numerator. 13, 4, and negative 93. Draw the line. Put a 0 here. 13 plus 0 is 13. 13 times negative 5, that's negative 65. Plus 4 is negative 61. Negative 61 times negative 5 is 305. Minus 93 is 212, and that's our remainder. Now, with a slant asymptote, the remainder doesn't matter. We don't care about the remainder. That's the rational part. We would put 212 over x plus 5, and we're ignoring the rational part. If we divided here, this 13 was originally x squared, right? Well, with synthetic division, don't we go down by 1 power? So we were x squared, now we're x to the first, right? So this is 13x to the first. So we'll have 13x minus 61, and so the slant asymptote is at y equals 13x minus 61. And that's how you identify a slant asymptote. Now, you're going to have to do a lot of practice to be good at this, identifying a slant asymptote, but I think with maybe at least 8 or 10 examples, 8 or 10 problems of identifying a slant asymptote, you should be just fine. And what we're going to do in the next class on Thursday is, well, watch the videos before then, but we're going to take all this information about horizontal, vertical, slant asymptotes, the x-intercepts, y-intercepts, the holes, and all that stuff. We're going to put it all together onto a coordinate plane, and we are going to graph rational functions. Okay? All right. I'll see you later.